Hi there, my name is Charles Wasfani. In this presentation, we are discussing factorization of the quadratic expression ax squared plus bx plus c. It is known this is a problem for many of us because maybe we don't see the systematic building up of such an expression, which is very important for us to be able to reverse the process of multiplication which delivers us this kind of an expression. Now, before we can tackle this kind of a problem, there are mathematical terms which we need to know. Like talking about factorization, we need to know what are factors. For example, if I've got a number like 18, I know a number 18 is a product. So also the term product is very important. Then 18 is a number which is got factors 2 and 9, meaning 18 is equal to 2 times 9, which is also equals to 3 times 6, and we also have got 18 equals to 1 times 18. So these individual numbers are referred to as factors of 18, and the 18 itself is the product of each pair of those factors. We also are used to this kind of command: remove brackets or expand. We normally use these terms when you are confronted with an expression of the form a plus y multiplied by a plus b. Now, in this particular case, let's say we've got in this particular, we need actually to understand how does this build up in order to be able at the end to take a squared plus bx, so to take ax squared plus bx plus c to the form of a product having two factors here. Now, I'll first of all like to take the most general form of factors of this kind of expression, which I'll write in as follows: alpha x plus m multiplied by beta x plus n. In this case here, alpha, beta, m, and n are constants and numbers, and for the purpose of a simple discussion, we are first of all going to take especially alpha and beta as whole numbers. They can be negative or positive whole numbers. Now, how having these two factors, which actually obtaining them is the task we are faced with in factorization. First of all, we need to understand that to get to this form, we have to multiply. In this case, multiplying here, we'll need the properties of numbers like the distributive law of multiplication with respect to addition, which says that A times in brackets B plus C is equals to AB plus AC. Now, I'll make a recommendation there that always when we're multiplying numbers represented by letters, we should always try to write the letters involved in alphabetic order. That will always help us to identify like terms and simplify wherever is necessary. So now, taking our first bracket here to play the role of A there, we're going to write alpha x plus m times beta x plus alpha x plus m multiplied by n. Now this removing brackets again, applying the same property, we are going to have this written as alpha beta x squared plus beta m x plus alpha n x plus m n. Now, in this case, we can see that these two here are like terms in terms of x. So we can take out common factor x there, right? Alpha beta x squared plus beta m plus alpha n brackets x plus m n. Now, having this now, we can see that we've arrived at the general form of the quadratic expression. We call this form of quadratic expression the general form of the quadratic expression. Now we've written it here in terms of, in the form that it suggests how we must go about with factorization if we know that the factors are of this form, more or less. So in this case, this is our C and this is our B and our A is sitting here. Now, this kind of presentation is the one I see as most suggestive of how we should go about our factorization. So what we can do now is to take a particular example and try to see how we can use this kind of writing to help us in our factorization. Now, the first case which we are going to discuss here is the simplest one, where A, our A is equal to 0. Sorry, I mean A equals to 1, which means our alpha beta is equal to 1. Now taking our alpha and beta being whole numbers, so alpha and beta have the options of being equals to 1 both, or both being negative 1. In that case, in what we saw before, this form of expression will look like as follows. Alpha and beta equals to 1. Then this will look as x squared plus m plus n, because beta is 1, alpha is 1. You've got that. Then you've got x here plus m times n. Now, if we look at the factors, this will come out to be x plus m multiplied by x plus n. That is, looking at the factors here, alpha is 1, beta is 1, then immediately we see that we get this kind of factorization. Now, with this now, we need to look at an example and see how we can use this to factorize systematically, not by accident, as usual most of us do. Now, let's get an example. Our first example will be x squared plus 5x plus 6. Now, our solution here, we should present x squared plus 5x in terms of its factors. According to what is suggested here, we're going to have x here and x there. So our task is to find m and n. Now, for organization, I'm going to draw a table. Now, our table is as follows. We've got a column for C, for B, and a column for checking. What is C? C is given here as 6, positive 6, and our B, we're going to put it in brackets here as 5. We're going to use it for checking. In this case, we need to break 6 into all possible factors. In this case, like 1 times 6. Now, since 6 is positive, we know that to get a positive number as a product of two numbers, both numbers got to be negative. Now it's multiplying negative by negative to get positive, or both numbers must be positive, multiplying positive by positive to get positive. So now here we need to have those combinations, those possibilities, all of them. And carefully here, we must always put this in brackets, because you can't afford to have something as clumsy as follows: minus times minus, or terms followed by minus. So we will put that in brackets. Then what follows here, we're going to have minus 3 times minus 2, and lastly, our last possibility is 2 times 3. Now this m and n in whichever order. Now what we need to do here now, we need to do this kind of addition and see if we can get our b, which is in the expression. Then we write 1 plus 6, this gives us 7. We check this against that, find that no, that's not what we want. Then we come to minus 6 plus minus 1, which gives us minus 7. Checking against that, we see that it's not equal. We rule that option out. Nextly, you get minus 3 plus minus 2, which gives us minus 5. Checking again against that, we see that this does not hold. And lastly, you've got 2 plus 5, sorry, 2 plus 3. I'm rushing to the answer there. 2 plus 3 equals to 5, which is what you've got there. Now, having that, we just need to look at how the factors are built up from x and m and n, and just then take these numbers and write there. And then you can say this has been factorized. We can quickly check by doing the multiplication like we did at the beginning and see if we get the exact expression. That is our first example. Now, to get used to this, we cannot get used to it by just doing one example and then waiting for evaluation like test or exam. We need to do several examples before we can say we are satisfied that we understand it. Now, our second example is going to be a similar one. Okay, our second example, similar one is x squared minus 7x plus 12. So in this case, our c is 12 and our b is minus 7. Now we need to break down 12 into its factors, which are minus 1 times minus 12. We've talked already about these signs. And then 1 times 12, 2 times 6, minus 2 times minus 6, 3 times 4, and then minus 4 times minus 3. Now, we can, looking at this, it looks long and tedious, but of course, at the beginning, we need to go through a long process so that you can understand it, and as we develop some experience in the week, we will be able to summarize and cut down a number of steps. And once you've understood it clearly, it will be very, very easy to maybe do 1 or 2 trials and you get to the right answer. But for now, for explanation, let's go through the long process. What we have here now, we're going to have minus 1 plus minus 12, which will give us minus 13. Now already we can start trying to kind of cut down number of steps. It is clear that there's no way we can get minus 7 from that. So we know that from these ones we're going to get 13, and from this we're going to get minus 8. So that is not minus 7. And here we're going to get 7, and there we get minus 7. So this is the option we're going to take. So now writing a solution to this exercise in terms of its factors, we'll say x squared minus 7x plus 12 will be equals to brackets x plus minus 4 multiplied by x plus minus 3. You can see there I'm writing, doing it the long way so that you can understand. I'm following this kind of suggestive formula form of the factors. I'm writing my plus, which I take from there, and writing m and n as numbers with their signs. Then the following step, then I can simplify by combining signs there by writing x minus 4 brackets x minus 3. Now this will be the factors, and you can check if they're correctly done. So from these two examples we've discussed, as form of practice, I would like to invite you to do some of the following exercises. When I'm saying that do the following, I mean factorize the quadratic expressions given. So now 1, we're given x squared minus x minus 6 then you have x squared plus x minus 6, then we've got x squared plus 7x plus 12 x squared plus 8x plus 15. All these exercises are of the same type because at the moment we're handling the simplest case where the leading coefficients, the coefficient of x squared is normally called the leading coefficient, where the leading coefficient is equal to 1. So in our general quadratic expression, a is equals to 1 for all of the following. Then we have x squared plus 2x minus 15. Now I'm going to stop there and invite you to pick any book which has got a similar kind of work and try to practice as much as possible until you are doing this in as easy way as possible. I said my name is Charles Suwasfani. Thank you for listening. I hope to see you to meet you in our next discussion.